and when you want to start, and you put the waveform like that, only one thread is going to mess up with this matrix here, so you shouldn't have any problem with it. So there's no shed. You don't need any shed variable except for C. C needs to be shared across. Okay? And even though it's shared, it will not be causing any problem. There's no race condition. Actually, matrix multiplication is very simple. Okay, should be able to get the answer. And if you get the answer and then the performance gain is a lot, maybe 6 times or 5 times, that's good enough, is it? For 16 threads. Okay, let's move on to the next one, which is QDA. Sorry. QDA is QDA requires you to know this. Let me explain a little bit about this. Okay, we're going to use compute unified device architecture, which is QDA, basically short form of that. And QDA is only available for, this driver is only for NVIDIA GPU. If you are not using NVIDIA GPU, it might not work. Okay, maybe AMD GPU might not be able to work. Okay, you have to check. Things might change, but previously it doesn't work. So if it doesn't work, you cannot use it at home. You can't do it, the exercise here. But I will show to you later on, not today. Maybe next week. You can use QDA, not on your machine, but on cloud services. In the cloud services provided by Google. We're going to use Colab. Okay, Colab is a unique system where we can actually write the same code, we put it there, compile it, and run it on the machine. Okay? And it should be able to run, it should give you the result. Okay? Now, if let's say you have QDA, you have NVIDIA GPU, download this, QDA download. Okay, download it, and then install it on your machine, okay, so that you can use it. Okay, I think the current version, I'm not sure whether it's 11.7 or 12, maybe it's already 12, but on the system here it's 11.7. Okay? I suggest that you install or you upgrade to 2022. Okay? Now, in order to do this exercise, we're going to use this link. Just click on that link. In fact, the code down below here, some of them is based on this text here. Okay, this document has been written 4 years back, and things has already changed. And it was written for 2019 Visual Studio. So it might not work on, the interface might not be the same. So some of them are the same, some are not the same. Yeah, I'm going to show it to you later, but if you missed what I said, you can always come back to the chapter. Okay, you can roughly guess, even though the interface is different, you can roughly guess how to navigate on Visual Studio 2022. Okay? And there is some differences because QDA code is evolving. Some of the header has been changed, the name has been changed, the library name also has been changed. I will show you, tell you what it is. Okay? So whatever I mentioned changes here, the one that you need to take note of. Okay? Otherwise, it will be exactly the same like showing there. Okay, first thing first, we need to create a new project. And we choose console app instead of a window console app. We choose console app. I have not tried window console app. Anyway, we are not using any Windows. We are not writing Windows program. Right? So console app should be fine. I think it's more compact. Okay, you type in console app at the top here, and you filter out a lot of your options. And this one will appear somewhere. Just click it. Okay, maybe I'll go through it now. Okay, double click on Visual Studio 2022. Create new project. Right over here, type in console. And this one will, okay, there are a few here. This is C#, VB, C++, C# again, VB, but this one is for .NET framework. Choose the C++, don't choose any others. Choose console and C++. Don't choose C#, it looks like, almost like C++, actually it's not the same. So choose C++, next. And here you can give any name. I'm going to give it P3 GPU or CUDA, it's up to you. Create. And wait for it to set up. Once it appears, you can see this program, skeleton program, and start try to run, just to make sure that it is working. When you run, it should show you hello world. It should see hello world there. Once you have tried that, you know that it's good to go, and you can start writing the program. Okay. Okay. So what do we do next? We have to configure to release. It is 64-bit. Release 64-bit. If it is not 64-bit, choose 64-bit. If you are using 2022, automatically it's 64-bit by default. In 2019, it will be 32-bit. Okay? Okay, next. The next thing is to enable this CUDA C++, C++. So Visual Studio has its own Microsoft Visual C++. But in order to program our NVIDIA GPU, we cannot use Visual Studio C++. Okay? Because Visual Studio C++ is going to convert our C++ into machine language of our native Intel processor. Okay? It's only for Intel processor, it's not for the GPU. GPU also has its own machine language, which is totally different. Okay? Now it doesn't know how to convert it, so we need another compiler. And that compiler is CUDA. It's provided by NVIDIA. NVIDIA also produces their own compiler, C and C++. And this CUDA is actually able to compile for two processors. One is for our Intel processor. The other one is for the CUDA. So in fact, you can use this to compile all the programs, okay? Because you can compile for both. Now, how does it convert to the machine language? Because these two machines are two different assembly language, right? Machine language. So you put a label on a function. Okay, when you put that label, it will know whether it has to be compiled to Intel machine language or GPU machine language. Okay, I'll show you what are those tags or keywords that is used. But first we have to enable it first. Go to here, right click, go to build dependency, build customization, and then you see this version. If you install the latest, I'm not sure, I think it's version 12. Okay, but ours one is level for 7. Click on that, click OK. Okay, so right now you have two C++ compiler, and then you have to choose. Later I'll show to you how to choose which compiler to use. And you can have multiple files in a project, and you can choose which file compiled by which compiler. Okay, you can mix them actually. But you're not going to use both, you're going to use one. You're going to use CUDA C++ for all our compilation, starting from now for this GPU. Okay? Only for GPU. Okay, next. We're going to add this dependency, which is the library. This library is needed because otherwise we have to program this GPU ourselves, and we do not know how to program it. We have to speak its own native language, and we have to configure it, and it's quite tough. So this library is going to help us. Okay, this library is going to help us do the configuration we just call the function that is provided in the library in order to help us do a complex configuration. Okay? And some helper functions to help us process all this data more efficiently. And that one is called QDA RT. RT stands for real time. QDA RT, and it has no static here for the current version. This one is the old version. The old version will have static at the end. So you go here, click, go to properties, go to linker, go to input, and here is the one. Okay, here is already there. I think all the machine is already configured nicely. I think the lab system will configured for all of us. So you go to put qda_rt.lib. Just now it's qda_rt_ static, right? This one no static. Don't put static because there's the old version. This one is the new version. And there's another one which is not listed there. This one is QDA development RT. Okay, QDA dev RT. It's a development real-time library. Okay, you need to add this one as well. I suggest that you copy and paste somewhere because when you install at home, this will not be there. Okay, if you have QDA, this needs to be there. And because your machine is already having this, we don't have to do any configuration. But at home, you need to add this. Okay, double check that it's there. If it is not there, add it in. Click OK. Maybe it's not clear enough. Maybe I will put it here so that you can see text. Okay. So this is the one. QDA RT lib, and then this is a semicolon followed by this one. Okay. Okay, next. Next is click OK. Okay, this one you can skip because it is already done. Okay, next is to add in new source. Okay, we're going to add a QDA header file. Okay, the header file we know for C it will be .h, for C++ it will be .hpp, header ++. For QDA it will be CUH. CU means QDA, H means header, .cuh. Okay, so we need that. And in order to add this in, this is the function prototype. I'll explain to you why we need this. In a short while, just click here, open it up, right click, add new item. Okay, here you just type in, I think it's kernel. QDA kernel, sorry. QDA. Anyway, any name. You don't have to use QDA kernel, but please make sure that it's relevant to the file. Because we know that our kernel is going to be inside here, so we call it QDA kernel. By the way, kernel here means function, just like our C function, C++ function. In GPU term, they don't call function, they call kernel. Okay, it's just a special name. Okay, basically it just means function executed by the GPU cores. Okay, so you add it. And then you paste this, just now copy that, paste it here. Here is a function prototype. And this folder, we're going to put all our definition, our, what else? Function prototype that is needed by the file. Okay, we put in one place so that we can import it using include. Okay, so that we don't have to like copy and paste this whole text. We'll clutter the program. So we organize it this way, and it's nicer. Okay? Now, because we already have this and we need it, and this kernel actually comes from somewhere, right? And it's going to be a program. We're going to put it somewhere. We're going to put it in here. So we add new items again. We call it QDA kernel. Not CU, right? Not CPP, CU. Okay? Not CU. Okay, anything that is not CU means is going to be compiled using CUDA C++. How do I know that? You right click, go to properties, and you can see that CUDA C++. Why? Because of the CU. And CU is the extension which Visual Studio knows, because we enable the CUDA C++, right? So when we enable that, the program actually initialize this, or maybe configure this Visual Studio to recognize that extension. Whenever it sees CU, it knows that it's going to be compiled using CUDA C++. Okay? If you add and then you forget to change it to CU, it remains as CPP, right? If you right click, you see that it's Visual Studio. It's not going to be this anymore. It's going to be this. Go to properties, you can see that C++ compiler. This Visual C++. You see this? It's different. Okay? But you can, of course, you can go back here and change it. Change it back to this. You can. But automatically it recognizes it, and then you will use the proper compiler depending on the extension. Okay? Now if you make mistake, I suggest that you delete the file completely, and then add a new one. The reason is because if you, let's say, you name it CUDA kernel, and then .cpp, right? When you press enter, it will initialize it. I mean, it will configure it for Visual C++ compiler. Okay? And then you go and change CU, it will not help. Even though you change CU later on, it will still be C++ compiler. Okay? So by the time when you create the file, it should be .cu. Yeah, otherwise the configuration will be wrong. Okay, the best thing is to double check. You go in and then check. It must be CUDA C++. Okay? Now this file just now, when I created the time, we automatically assign this C++ compiler, which is Visual Studio Visual C++. And I don't want to use it. I want to use CUDA, so I go and then change it. Okay, so I change my P3 CPP to CUDA C++. It's alright because, as I told you before, this CUDA C++ can compile for two machines. One is for the GPU, one is for the Intel processor. Okay, and we can tell which code is to compile to which machine language. Okay. Okay, once you are done with that, okay, we are ready to write the code. Actually, you don't have to write the code, you just copy and paste. Copy this, sorry, and then paste it. I think there's a button to click somewhere so you can copy the whole thing. But anyway, you can copy and paste. Okay, you see this underline with bigger red line is because, as I said before, it has changed. This header has changed because CUDA itself is evolving. They move things around and it's not going to use this anymore. So we're going to add some more because it's split it into multiple files. This CUDA runtime.8 actually comes from CUDA. When we add the CUDA C++ just now, we add the library just now, right? Additional library, CUDA RT and CUDA development RT, right? So that contains this one runtime.h. So we include it here. Okay? Now if we don't add just now the library, then this will not be visible. Okay? You see wavy underline for this CUDA runtime because it cannot find. Okay, you have to add that library there first. Then only you can this one will work properly. Okay. Now not only this, you need to add one more. Sorry. You have to add two more actually. Another one is CUDA. Right? And then the last one we have to CUDA parameters, I believe. I remember parameters. Parameters. Okay, we see wavy line of this, that means you cannot recognize it. I think I wrote the wrong name. Let me go and check. Give me a while. Because I cannot remember the
Corner. Series. 一个 CU 一个 series。
Sorry, it's this one. The name has changed. Even this one is so different from the current one already. Let's go back to code, which is this one. It should be this. Okay, device launch parameters. Okay, we move this H there. And you see this wavy line disappear in a short while. Okay, it disappears means I recognize this. It means it can find, not recognize, it can find this. After I add the library just now. Okay? So you need this tree. Okay, if you don't add this tree, you will see wavy line underneath this global. You see wavy line, there's not wavy line under this, right? And this and this. Okay? If I remove this, you can see the wavy line comes back again. Okay? If I remove all this, you see wavy line will appear on many different places. Okay, this one, okay, and then down below this one, okay, all of them will be on because all this is inside here. So you have to add all this through. Okay, then only the wavy line here disappear, the wavy line underneath this also disappear, the wavy line underneath this also disappear. Okay, all of this. Alright? So once you don't see any wavy line, it means that you have already included the correct header file. Okay? Right. So how does the QDA know which function is to be compiled to our native Intel x86 or x64 processor or GPU? It looks at this tag, this keyword, global. Okay, if you tag it with the global, it means that this one is for the GPU. Okay? Any function that is no global appended in front, it means this is for our native processor. Okay? So the one that is the global is the one that is going to be compiled to GPU. Right? Okay, GPU, QDA don't call this one as function, they call it kernel. That's why you see kernel and kernel. Okay? It's just a fancy name of the same thing. Okay, it's actually function. Kernel is just it means call function that is executed by multiple cores, okay, or multiple threads. Now, if you look at the code inside this GPU, the way we write is more or less the same like OMP, the other way that we write. Okay, because we need to tell which core to do what. Remember, in the OMP, we have to get the thread ID, remember, no? And then we assign, in our for loop, we assign, okay, you ID for this, you should only add for the certain strips, for the find pi, right? It's the same thing here. So you find the thread ID, and then you tell this if statement is to tell the thread. If the thread that is running here and the ID is that, then you start to do this. If it is not, then you will not do it. You will let other thread do it. Okay? So here what we do is, because there are many threads that can be created in our GPU, we can have like 1024. I think that's the maximum for our GPU. And when it comes in, okay, it will do this kind of job. But if let's say we don't need so many threads to do it, right? Then we can use this condition. This condition is to tell the threads, if you are not within that size, then don't do anything. just skip it. Okay? So array size, let's say, is only 10. So only the first 10 threads will execute it. The rest of the thread will ignore it. It will come in and execute also, but then you skip this if statement because it's not the function. Sorry, the statement is telling the thread you shouldn't do anything. Okay? Here you can see the first array size thread is going to execute it. Otherwise, don't do anything. Okay? The job is very simple. It's actually a vector addition. I'll explain to you what that means later on. And one thing that is different here is this. This one is a bit complicated because you have to compute yourself. It's unlike OMP. You just call OMP get thread number, right? Yeah, thread number. So basically, you return you the thread ID. But here is a bit different because you can configure the GPU. Okay, you can configure how many threads in a block, how many blocks in a grid. Okay, if you change that, and this value also will change. Okay, this value will change according to how you configure it. Okay, and unfortunately, there's no function because of this of the way you configure it is very flexible. So GPU, the CUDA force you to calculate yourself. Okay? And this is not on the only formula, but most of the time we are going to use this. Right? Now, how we come up with this formula, I'll explain to you in the lecture later. Not now. I'll explain to you why it is written this way. Okay? And what is the meaning of this. But for now, we use it first because we just do the exercises provided. Okay? Alright. Next. We're going to look at the kernel, and the code is very lengthy. The one that launched the GPU is actually this one here. And how do I know this is to launch the GPU? This code is all run by your native processor, Intel processor. Okay? But when you reach here, the CPU is not going to execute it. It's going to let the GPU execute. When the GPU finishes executing it, you pass the control back to the CPU will continue to run. Okay? So the computer, your native computer is going to run the kernel just now, right until here. Okay? And then the CPU will tell or will invoke the GPU. Okay, it will invoke the GPU, do the job, and then the GPU once finished, will tell the CPU I'm done, and the CPU will continue executing. Okay? Now, what are all those? Okay, let's have a look at our document. Those code actually is do all this. Okay, in summary, these are the 6 steps that you need to do. Okay, some are steps you don't have to do always, but in the end you have to do it. Okay, I'll explain the one. This one. I'll explain to you the last one. You can do it one time at the end of the code. Okay, but at least you have to do it once. Okay, first thing is, let's look at the architecture first. The GPU and the CPU actually is 2 separate entities. And it's also on different boards as well, right? So you got the main board, which is the motherboard, and then you buy the GPU, and then you put it into the slot. So there are 2 different boards, right? And the GPU is on the special board, or the daughter board, and the CPU is on the motherboard. So these 2 are 2 different entities, and they are connected through this very ultra high speed bus. Okay? And one thing good about this ultra high speed bus is that the GPU and the CPU can access the memory directly. Okay? Any other devices have to go through a special controller. This controller also can access the high speed bus, just like the GPU and CPU. But it is actually like a controller or the manager to allow the rest of the devices or slow devices to get access to the memory. Okay? But then this device cannot access directly. Only the privileged one, like the GPU, CPU, and this controller. Okay? The I/O controller we call it. Okay, this ultra high speed bus is the way for the GPU, CPU to get connected to the memory. Okay? Because memory is a place where all the data is. Okay? Your GPU also need to process the data is etc. Now there are two sets of memory. One set of memory is actually on the GPU itself. If you buy the GPU, you can see there are a lot of black chips at the back and the front as well. Those black chips are onboard memory for the GPU. Okay, when you attach onto the motherboard, the CPU is also able to access it. It's able to see the memory as well. Okay, but the GPU, it can only see its own memory. Okay, it might not be able to see the memory on the motherboard. Okay, it might be able to see, it might not be able to see. It depends on how the CPU configures this GPU. Okay, so there are two sets of memory, but it is living in one address space. Okay, so 0 to maybe 16 gig or more, or maybe 1 terabyte. Okay. Okay, so the memory address is linear and they're all residing on this memory space. Just that the location might not be at the same place. Some on the motherboard, some will be on the GPU. Okay, but they're all living or they appear in the memory address space. Okay. Now the CPU can see all. The GPU might be able to see its own one. It might not see this. Okay. Now, in order for us to allow this GPU to process the data, and most of our data is in the CPU. Why? Because when you run a program, you load the data maybe from the hard disk, right, into the local memory, your external DRAM, right? And your memory is not below here. Okay. And this special memory actually belongs to the GPU. You don't touch it unless you need it, right? But the GPU can only process the data which is inside here only. So you need the CPU to copy it over. Okay? You need to copy it over. But before you copy it over, you need to allocate memory first. Why do you need to do that? Because GPU also you can have multitasking, right? You can run multiple programs. The same thing as CPU. So you need to allocate memory. Okay, allocate the memory so that nobody touch it, and then you copy it over. So that is the first step. Okay. So you tell the CPU will run the QDA library, and that QDA library will help the GPU, or actually it will allocate the memory in this space belonging to the GPU, right? So that you can copy over the data across, right? So that is allocate device memory. Why is it called device? Because GPU is a device. Okay? The CPU, we call it host. Host is the person who is managing the whole system. Okay, we call it host. Just like you are the host in the house, right? Your guest is coming in, so the guest is the device. Okay, you are the host. Now the GPU is the device. The rest of the things also device. Let's say a sound card, okay, your USB drive or your hard disk, they're all devices. Okay? So when we say device memory, it means GPU memory. Okay, so you allocate the GPU memory, and then you copy the data inside the CPU memory to the GPU memory. So that is copy host memory to the device memory. Okay? So that the GPU is able to see and able to process it. Okay, the next thing is you need to configure this GPU. Remember I told you that you can adjust, for example, how many threads in a block, how many blocks in a grid. Okay? So that the GPU knows how to assign the core and execute what. Okay? So, but then that one I have to explain a little because it's a bit more complex there. But you have to configure the GPU. Okay? So that is a step, how we configure it. After that, we invoke it. Invoke, that means the CPU will tell, okay, right now I already configure you, I already copy the data is there, now you start to process it. So that is invoking CPU kernel. Okay? And then you wait for the GPU to finish. Once it's finished, the GPU will indicate to the CPU, okay, now I'm done, you can continue. And the CPU will copy back the result from the device back to the host. Copy it back here. Okay, and then process it. Okay? Now, if you're wondering, why not? Why you copy? Why not use the data? The data is there, why you copy it? right? The reason is because this memory is limited. Okay? Remember, the GPU can be used by other multitasking programs as well, right? And this is limited, so you copy over so that other tasks can allocate it and then put the data in the processor. Okay? So you need to copy it back here because this is limited. This one a lot, but this one is limited. Okay, so you have to copy it back and then you deallocate it so that other process can use this limited memory. Okay? And they can use the GPU to process the data. You have to deallocate. Okay? So all together you got 6 steps. The reason is because of that. You understand? Okay, so you have better understanding now why there are 6 steps. Okay, that 6 steps translate to this. Okay, you can see here, you got the pointers, which is ABC. Pointer to this, pointer to this, pointer to this. I'll explain to you later on. And then you allocate the memory for the vector, or maybe I'll explain this one first. Okay, what we are trying to do here is this exercise. So that you have an understanding of what are you allocating. We're going to do vector addition. The first one is serial, that means single track. The second one is parallel, that means multiple tracks. Okay? The single one is because we want to check whether the parallel answer is correct. We can do double checking. And we can also measure the performance gain compared to single tracks. Okay, so the serial vector addition, there's a code there. You can click and open up. There's also code for the parallel, but that code is actually the one that we already copy over. This one. Just now I copy over, right? This is the code. It's this one, exactly. Okay? So what does it do? Let's have a look. Okay, we have learned the matrix multiplication, right? The matrix multiplication, the matrix is 2-dimension data. Okay, 2 dimension. A vector is 1 dimension. Okay? Basically they are from the same family, right? And if you multiply in the matrix, you multiply this way. Alright, you multiply and then you put the data there and then you move on to the next one. Okay, and you put the data there and you fill up all this. Okay? Now how do you do vector multiplication? A vector is a single dimension, so it's much simpler. Okay, this one is addition. Multiplication will be something like this. If we do vector multiplication, here will be your vector. Let's say there are 5 there. You multiply with this. Okay, you need to transpose it. Okay, transpose, that means you have to reorient it. Okay, okay, transposition we call it. So this is one vector. The other vector, you have to transpose it, then only you can multiply. Okay? When you transpose, now you can multiply. And the way you multiply is the same like the matrix multiplication. You multiply this, multiply this, multiply this, multiply this, multiply this. And then you add them together and you get a single answer. Okay? So vector multiplied by vector, you get a scalar. Scalar, that means you got only one data, which is not in array form. Okay, this one is an array, you got multiple data, multiple numbers, right? So scalar is only one number. Okay, so a vector multiplied by a vector, you get a scalar. A matrix multiplied by a matrix, you get another matrix. Okay, so that's how you multiply for matrix, multiply for vector. Now, how do you add? Add is the same. You add these two, and then you put the number inside there. You add the second one, and you put the data there. So adding is very simple. It's just very straightforward. Whatever cell in A and B, you just add together, and you put in the cell in the C. Okay. And here also the same thing. When you add, you take A and H, you add, and then you add. You place it in the first element of C. And then you go to the second element, B and I, and you add it. And you place it here. And C and J, you add and you put it there. And so on and so forth. Okay, so a vector, add with a vector, you get another vector. Okay, subtract also the same thing. A vector, subtract with another vector, you get another vector. Right? Okay, this is the rule of the vector. Okay, and as I told you before, the vector actually is very useful. A lot of mathematics problem can be reduced to this vector or matrix, and then we solve it. Okay, and we have solver for matrix and this, so it's very simple. So what you need to do is just to convert your problem into this matrix or vector, and then you use the solver to solve. Right? Meaning that if you've done this once, then whatever problem that you have, you just do the conversion and then you let your solver solve it. Okay, your GPU to solve it. So your GPU only see matrix. It doesn't see anything. It doesn't know what is the problem, the actual problem. Right? And it doesn't need to know also. Okay, that is one thing good about mathematics matrix. Okay, because we have all the solution in one place already. The problem, you just need to convert it only into this form, and then the solver will solve it for you without it knowing what they are solving. But then you still get the result. Okay? Okay, so next, what we need to do now is to understand this. Let's get back to here. Let's look at this code here. Remember I mentioned to you when you add, and then you put it there. This is basically what it does. Okay, let's see. Here we let thread 0 do this, thread 1 do this, thread 2 do this, thread 3 do this. And all of them will be doing in parallel. Right? So if they can execute it in one clock cycle, then that means this vector add can be done in one clock cycle. Okay? If you use single thread, then you have 7 there, right? So you need at least 7 clock cycles to do it. Slower, right? So that's the reason why we use ParallelComputing in this case here. Well, of course, this one is very small, but normally the vector is very, very large. The matrix also very, very large. So we get a lot of performance gain. And you can see here, A, thread number, let's say 0, will be 0 to as well. Vector A, vector B, vector A, vector B, 0, 0, 1, 1, 2, 2, 2, 2. And then the result will be placed into 0, 1, 2, 3. Okay? So very simple, huh? Okay. So that explains that. Now how about this? Okay, this one is the pointer pointing into our A, B, and C in the CPU memory. Okay, so that is a pointer pointing into this vector which is residing here. Now, you want GPU to solve the problem, you have to allocate memory first, exactly the same size as this, in here. That means an image of this, and then we copy over. And to allocate that memory, we don't use malloc, we use malloc. So malloc is going to allocate the memory here, not here. You use malloc, it's going to allocate here. malloc is going to allocate here. Right? You have to use the correct malloc. So memory allocate. And the size is in bytes, right? That's why array size depending on what you input there. And then the size of double is 8, and you multiply by 8. Okay, because this number here must be in bytes. Okay, not the number of elements, but the number of bytes that is required. And then you let DC points to it. That means ABC is pointing to the original one. Okay, DADBDC is going to point to the newly allocated memory in this GPU memory. Understand? So you got two sets, right? And they are exact copy. Okay? Alright, so once you have done that, now you copy the data. Just now you allocate memory only. Now you copy the data. And you only need to copy the AB only, because C is the result. You don't need to copy, right? Okay? You might need to initialize to 0, but you don't have to. Because later on, if you look at the code here, actually this is too simple that you do not need it. You override the data, so you don't need to initialize to 0, because you are not summing up, right? You just override the data. So you don't have to initialize to 0 in this case. Okay, if you are summing up, then you have to initialize that C to 0. Okay? Okay, next, after you transfer the data, exactly the data, and you have to check the direction, memory copy, and here the instruction is to tell that function to copy from host to device. Okay, host to device. Right? because you can copy from device to host, the other way around. It's still Q down man copy, just that the right direction is different. Okay, next. After you've done that, you configure the GPU. Remember, you have to configure it here. This step here. Okay? The third step is to initialize, and that is done here. Actually, this haven't been initialized, we just create it. We create the block size. The block size is 512 threads inside the block. And then how many block inside the grid. Okay, so we do some calculation there, and we do not know at the moment. I'll explain to you why. We use this formula later. But this is the number of blocks in the grid. Okay, we have to configure at least these two. There are many more that we need to configure, but for this simple example, only this two. Okay? Next, once we already configure this block size and grid size, we use it here. Okay, we use it here, and you can see this symbol here. This symbol is not recognized by Visual C++, because this is not Visual C++. This is only recognizable by Q.C++. Okay? So Q.C, when it sees this, it knows that you're trying to invoke the GPU. Okay? So the CPU will invoke the GPU. It will not execute this. It will let the GPU do it, and then you wait. Okay? Once this GPU finish doing it, okay, it will inform CPU is done. Then the CPU will continue the program, running the rest of the program. Okay? So this vector addition kernel, okay, if you put this one is called CPU QDAO configuration. It needs to be running in this kernel, and this kernel must be tagged with this global. If it's not tagged with this, then this will fail to compile. Because you cannot use this if this is not tagged with global. Okay, so it needs to be tagged with global because this needs to be compiled to GPU code. Okay? So you call and then you pass in this, okay, which is this one. Okay, you pass in this A, DA, DB, DC, and then the size. Okay? You also pass in the grid size, the block size as well, which we configure here, so that it knows how to configure the GPU before it executes this. Right? Once it is done, it comes back to the CPU. The CPU will copy the data from DC back to C. How do I know it? Because it's device to host right now. Just now it's host to device. Now it's device to host. Okay? Back to the local memory. Okay? Once that is done, then this function is complete. Okay? It will be back to our program, the caller. The caller will going to print out this C. Okay? Let's do that because the code is not there. So let's try to do it. I think the code is there. You just copy and paste. Go back here. Yeah, this is the code. Okay, I'm going to copy this, but I'm not going to call main because we have already a main. Just copy this. Copy that. And this vector is very small, only 3. The size is 3. You see here? A3, B2, C3. And the data is 5, 8, 3, 7, 6, 4. When you add, you should get 14. Sorry, this one 12, 14, and 7. Okay? And that is where you will print out here. Okay, here is the place where we call the kernel just now. This one. So this kernel. This kernel is going to initialize, launch the GPU, copy the result back. So once it gets back to here, C will contain the result. And that result is not done by the CPU, it's done by the GPU. And then you print out the result. You print out the three elements inside the vector C. Okay? So let's put the code here. Okay, then we're not going to call it main, we're going to call it simple vector add. call this simple vector add. And this kernel is not visible, right? You see the on the wavy line. Okay, we need to copy this header. But remember, this header was inside this qda kernel.cuh. It's already in there, right? Okay, we see a script there. Save it first. Or maybe it's good on this better. Save for all. Okay, you just need this header inside there. Okay, so put in there. qda kernel.cuh. Okay. So once you include that, that means this is also included into the file, into this file. So if now we can see the kernel, and now you don't see the wavy line anymore. The wavy line disappeared, right? Because right now you can see the function for type, so it knows how the function looks like. And then to double check with this, there's no error, so there's no wavy line. Okay, there's no error, no warning. Okay, so once that is done, now we can start calling it. Call it from our code here. Okay, and then you can run the program. And we should see 12, 14, 7. Hello world, 1247. Right? Again, this 1247 is predictable because you had, right? Vector add 1. And take note, this is not done by the CPU, it's done by the GPU, although it's only 3, which is very simple. If the GPU wasn't invoked, then you see garbage there. Either you see 0 or you see garbage. Because the GPU did not run it. Right? Okay, this one is done by the GPU. Just that maybe you don't feel it is GPU because it's very fast, because it's only 3. Later on we will see it. If you run by the CPU, how fast it runs, and run by the GPU, how fast it is. And we're going to put larger value, maybe 1 minute, or maybe 10 minutes. Okay? And we will see the performance gain. Okay? And then only you will know whether this one is run by the GPU or the CPU. Okay? Okay, even though with multiple cores, even though you run CPU with multiple cores, you cannot beat the GPU. Okay, because the GPU has more cores. You can see how many cores that we have there. There are many more cores. And each core is running at gigahertz as well, so it's as fast as your CPU. And there's many more cores to actually execute. Okay, now let's do some exercise. But first, we want to do we're going to do something similar like this. Is vector add is not a simple vector add, but slightly more difficult. Okay? And the code is already here. So we go here, go serial, vector addition. You can open it up or just download. Show why you have to download. And that should be able to see it. Go to text editor. Okay, if you don't have text editor, I think you need to install, you need to give permission, because the text editor is not Google feature. Okay. This one is outside Google. Okay, now you can just copy and paste here. Just copy this. And let's paste it in main, or maybe we create a new one. Not sure. Shall we create a new one? Or maybe just paste it much easier. Just paste it. You can create a new file if you want to, and then add that in. I'm lazy to do that. I'll just add it here. Okay? And change the function. Let's call this void vector add. Sorry, we're not going to call vector add, we're going to call serial vector add, meaning that one track only. Okay? Or you can call single track vector add. Okay? So this one is kind of similar like this now, the simple one, except that this one is going to be run by the CPU. Another difference is, just now ABC is very small, it's only 3, size of 3. But this one is going to be size of this size. Okay, so cut this, and put it at the top here. Okay? So it's going to be this size, or you can increase it if you want to. Maybe you want to increase it to 1 million. Let's try 1 million. Okay. Okay, if you multiply this, you have, please put a bracket there. If you don't put bracket, you get a lot of problems later on. Okay? Bracket means do this multiplication first. That means you multiply these two numbers first before it is used in somewhere else. Okay? So I increase it to 1 million, but you're not going to print 1 million, you're going to print the first 10. If we find out the first 10 is correct, most probably it's also correct for the rest. Okay? Okay, so first thing is we initialize because with malloc. This time with malloc, when we use malloc, is malloc inside this memory. Tilde malloc is here, malloc is here. Okay, we don't use the same technique as before. Just now it's only size of 3. We can use static memory allocation in a stack. But right now we don't do that. We allocate it using malloc dynamically inside our heap memory. Okay, we use malloc because it's going to be quite long. 1 million, 1 million, 1 million. An integer is 4 bytes, so it's 4 million, 4 million, 4 million bytes. That means we got how many bytes left? 12 million bytes. Okay, we don't have enough stack left, so that's why we dynamically allocate memory. A, B, C. Okay? And we initialize A and B to this number. A, we initialize 0, 1, 2, 3, 4, 5. So the element number, the element next number is the data that it carries. So 0, 1, 2, 3, 4, 5. Right? How about B? Also the same thing, 0, 1, 2, 3, 4, 5. How about C? C is all initialized to 0. Okay. Next, we vector add, but this vector add is not GPU. We are not invoking GPU because there's no that angle bracket. And also this vector add is this vector add. It doesn't have global in front. It means that this is a normal function. It's going to be executed by the CPU. Okay? So the CPU will do the same. Now we are asking the CPU, that's why this one is called serial right there. Because CPU is going to do it. It's also the same, you iterate through the vector from 0 to n. N is going to be the size, is going to be 1 million. Okay, and then you add this A and B vector element and add it into the C element. So basically it does this. Take A, take H, add it, and then put it into C, one by one. So it's the same as what you see just now, right? So that this one is going to be executed by our CPU, not the GPU. Yeah? So once we have done that, then we print out the result. Okay, after you print, because you allocate dynamically early on, you have to free. If you don't free it, then this memory is going to be occupied. And if you run this for a while, you run out of memory. Because you keep on allocating memory without releasing, the memory will be disappear, right? It doesn't have a infinite amount of memory. So somehow, if you reuse and you don't release, then you run out of memory. So every time you are done, free the memory. So we free that memory. Okay, because I'm not going to use C printf, I'm going to use C out. Let's change this. Change it to C++, C out. And this is going to be C. And this is going to be I. This is going to be this equal. And then CI. And then and 9. as what you see at the top here. Okay, I'm going to delete that. And you see wavy line here and here. The reason is because we have to import, because it's already there. It's because namespace is not that it's not correct. We have to include the STD namespace because I was lazy to put STD at the front of this slide. Okay, so I have to add that statement just now. Okay, so right now I can run. Before I run, I remove this return 0 because it's void. It should return 0. So I should remove that. Okay, so simple vector add that's done by the GPU. But this one is a more complex one. It's 1 million. So it's not simple. And I'm going to call it. And it's going to be executed by the CPU.
Using namespace STD.
And you see the result. Okay, the first result here is that one is produced by the GPU. This one is the one that is executed by CPU. And we show only the first step, even though there's 1 million vector actor, 1 million elements. But we show only the first time. Let's see whether it's correct. 0 plus 0 is 0. 1 plus 1 is 2. 2 plus 2 is 4. 4 plus, so 3 plus 3 is 6. 4 plus 4 is 8. 5 plus 5 is 10. 6 plus 6 is 12. So it's correct, right? So we know the first few is correct. That means the rest also will be correct. Right? Okay? So that is done by the CPU. Now I want you to change it to run using the GPU. Okay? Refer to the simple example here. Refer to this. Here's the code. This one. Okay, we're going to do something similar like that as well. Right? Here's this. Okay, refer to this and refer to the kernel. The kernel is basically here. This code. Okay, you have to initialize this, allocate memory, transfer. Create the block size and invoke the vector addition kernel, and then copy the data back to the main memory, and then print it out. Okay, so you're going to do that. Okay, to help you out, so that you have, so that we can move faster. I'm going to fill in some blanks, fill in some part, and then you fill in the blanks. Okay. So we're going to call parallel vector add is going to be solved by our GPU. Okay? And this one and the simple vector add is more or less the same. So I'm going to give you as an exercise, but I'm going to do some part and the rest will fill in the blanks. Okay? Just refer to the simple vector add in order to do it. Okay, I'm going to put it where should I put it? I think I'm going to put it inside the vector. Okay, I'm going to put it here. Or maybe I'll put it here. Let's create a new one. Add new item, and here let's call it kernel, or so vector add. Yeah, I'm going to put my code in here. Okay, void. And that's all. Okay. Okay, I'm going to copy some because I'm lazy to type. Okay. We're going to copy from the serial vector. Copy it. Okay. So everything exactly the same except this part here. Okay, so this one is GPU vector. Let's call it GPU vector. Okay? GPU vector F is going to be here. Okay, our GPU vector F is going to be, okay, now this is size. This is integer. Integer. Okay, so that is our vector A, B, C, and size. Okay, the vector size. And now I copy from here because I'm lazy to type. And actually I have nothing to copy. I just want to copy this one. Go back to that. Paste it here. Here is not double, it's going to be integer because the simple example is actually double. This one in our case is integer. Okay? So we have a pointer pointing to a copy of A, B, C inside the device memory. I call it D8 A, B, D, C. Okay? And here is the allocated memory. And again, here because we allocate memory just like here, we have to copy this whole thing. Okay? Copy it here. Alright. So we're going to use map copy and all that, so I'll let you do. Okay, figure out how to do that. Refer to this program, you should be able to know what needs to be done. Okay? Don't copy it blindly, yeah? Because you have to do some changes. But basically it's just like this. And then you transfer array A and B to device. Okay? So refer to this. And again, don't copy it blindly because you have to do some changes. If you don't, you get the wrong answer. Or it might crash or it might not give you the correct answer. Okay, transfer A to B, refer to this. Okay, you're going to do something similar like this. Certain things need to change. You're going to find out. Okay, this one I'm going to do it for you because the size is. Okay, I'm going to reduce the size because otherwise the problem can be quite challenging for you to solve. Okay, I'm going to use the maximum core for the X. So this block size that we can configure the X, Y, and Z. Okay, because GPU is meant for 3D animation, right? So you got X, Y, and Z dimension. So this X, Y, Z. So each dimension we can assign multiple cores, or we call it thread. Maximum here is a 1024. 1024. This one I believe is not necessarily 32 or less, or somewhere around there. Here the Z is less tracks, maximum track that it has. Okay, so I'm going to use 1024. It's also 1024. Because the maximum track is 1024, so I'm not going to exceed that. I know our problem is 1 million, right? If it is 1 million, then you have to configure your free size properly. But right now I'm lazy to do that. I don't want to make it so complex for you to solve. I'm going to use a simple example. Just now I put 1 million, I think it's a mistake. I go back to this size. Okay? Go back to this size. Okay, the reason is because I don't want to go and meddle with this. You have to configure it differently in order to solve 1 million. Okay? Because we have a limited number of cores. GPU also has a lot of cores, but it doesn't have infinite amount of cores. But definitely larger than our CPU. Our CPU has less cores. Here we have a lot more cores. But you have to configure it properly. But because I'm lazy to configure it, I'm going to use a simple way. a simple example so that we don't have to make any much changes here. Okay, this is going to size here. Okay, so only this one that I do it for you. I configure it for you already. Next is to launch. Okay, but because vector addition kernel is actually double. Ours one is integer, remember? So we're going to create that ourselves. Okay, and let's call that this. Okay, so but I'm going to change the name slightly. And then you figure out what to put inside there. Refer to the code here. Refer to this code. And then go and figure out what to put inside there. So that's a simple exercise for you. And here should be integer. Okay. And this one is vector addition kernel. Let's call it int vect kernel. Okay. And this is the one that we're going to call here. Okay. Don't call the wrong one, because we are using the integer, not double one. Call the correct one, and then you fill in the blank here. So put that. Okay. And why we cannot reuse this? The reason is because this one is for double. Ours is for integer. The code is more or less the same as this. Right? Not much difference. So we go back there and then fill it in here. Yeah? Okay, once they are already launched, now we are ready to copy it back. Copy the array C back to host memory. Okay, so here. Once it's done, when you get out from GPU vector add, which is basically this one. Okay, then we print out the result. Okay, I see there's a problem here because our string is missing. Our string without the H. Okay. Once you put this, then you don't see any really line here anymore. Oh, we still see really line because of the namespace is missing. So we're using namespace std. Okay, once you do that, now the really line disappears. Okay. So right now I think I'm done with that. Okay, next. Parallel vector add needs to be visible, so we're going to put it either directly into here, but I suggest not. We open up here, add, new item, let's call it vector add kernel dot cuh. Okay, we add the normal that and put it here. Okay, and then we include this vector add kernel inside all that is needed, which is basically this one. Okay. Okay, what is the meaning of this dot slash there? In Linux, because this code actually comes from Linux source code. In Linux, and also in Windows, also the same thing. But then it's more prominent in Linux. In Linux, you have to tell where you want this to find this. So here we are telling the compiler, look into the folder where this file is. Okay, and look for that header file, CH. Okay, because this file is living inside the same folder. So that dot slash is actually look inside this the folder where this file is residing. Okay, it's just telling the compiler to look for that file inside the folder where this file is. This file is called vector@kernel.c. Okay, so it must be in the same folder. If it is not in the same folder, then it will generate an error. Okay, and you need to be sure because you might have the same name in different folder, and it can be a problem. Okay, you have many files with the same name but in different folder. So the CPU, if let's say you cannot find in the current folder, you go and look somewhere else and then edit it, and they add the wrong one, right? So that is actually going to solve a lot of problems, because if it is not inside the current folder, then it will generate an error and you know something is wrong. Okay. So I add already. And what else? Next is I want to call this. Oh, sorry, before that, I need to add this into my here as well. Otherwise, you won't be able to see it. Okay. So now you don't see any wavy line there. Why? Because I already added this. If you don't add that, you see the wavy line there. Okay. Because this vector@kernel is this one, and it has this parallel vector add function program. Okay. Now save everything, and then you can run the program. Well, of course, in my case, I think it print nothing there because I did not run any code. Okay, there's some problem. Let's have a look. Okay, size problem. Okay, just now I have a size here, which is only this. I'm going to copy that, put inside here. Okay, put it here. Alright, and then remove it from here. I don't need it anymore because it's already included. Okay, and also it get included into here as well because I include this. Okay, just my define is here. This is how it's called, and I include it here, and I also include it here. Okay, so it should solve that problem. I'm going to run the program. Okay, let's run again. Oops, sorry, run again, and you see the first one is by the CPU. The second one, you see all zero. Because they did not invoke the GPU, right? I don't have the code, right? I did not configure, right? So if you fill in the blank, you should see 0, 1, 2, 4, 6, 8, 10, 12, and so on. So exactly the same like this, except that it's going to be executed by the GPU. Okay, you just fill in the blank. Refer to the code here. Okay, refer to the code here. Don't copy blindly because there's certain things that need to change. Yeah? So that's an exercise for you. Right? Allocate memory, do the transfer, launch, and then copy the result back. Okay? That's all that you need to do because I have done all the parts for you already. Okay? Now, if you get that, then basically you have done the job where you invoke the GPU. The GPU actually solved the 1024 vector addition. Okay? And after you finish it, now we want to characterize it. See how fast the problem is solved. Okay, we're going to use NVIDIA profiler. Okay, the NVIDIA profiler will tell us how fast the program runs. Okay? And then we compare with our original code, which is serial, and see how fast compared to the CPU. Okay? From there, then you can see the advantage of using GPU. Okay? Because the GPU is going to solve very much faster than the CPU. Okay, try that, and you have. I give you 15 minutes to try. Actually, it's quite simple. You just copy and paste, and then you just change certain part. Yeah. 15 minutes, and then 15 minutes to discuss the second part where we want to profile, which is this one. Okay, this is the profiler to run, and then we can see the timing. There's a timing there, which tells us how much time that is spent inside the kernel and also inside the function. Okay, And then from there we can gauge how fast we solve the problem. Okay? But then you have to write the program first. Get it to solve the problem first, then only we can profile it. Okay, the profiler is basically just find out the performance. Just like you go get your blood test, right? The doctor actually profile your blood, and then he give you the result. The same thing here. So that you know your health. So here we want to know the performance or the health of the result.
它的erasers 跟这个是一样的，
应该要一样。
这样组是同一样的，是不是？
嗯？
这组是一样的，是不是？都是上面这个是
啊，上面是 eraser 嘛，这是 size， 应该要放一样才对。这边改成 size 了。
不是它上面这边小写上面大写，也是要全部的东西。
应该放小写。
Just copy and paste, and then do adjustment. I suggest that you type better, because you type will remember. You copy and paste, you cannot remember much. Okay, I'll give it 15 minutes and then we proceed on to this. Good. Let's see that we make some changes there. Right. Huh? Why not? No. I'll show you all the stuff there. Here is a GPU. One play or one shot or something like that. Should this one come from the file, just copy and paste. Okay, so this vector add, also copy and paste from the original file. Okay, this serial also said that I just changed. Actually it comes from the serial vector add. Okay, we go to the over here. This one. Go here. It's actually this folder. I just changed the name from main to this, that's all. And then I put this on to board. And I remove the return 0, that's all. Yeah, exactly the same. And then the main, this is the one that I add in. Yeah, simple vector add, 0 vector add, parallel vector add. Get it? Okay, so that is quite simple because I cut and paste also just now. And then at the top here, you have to add this. Okay, you don't need this anymore. This one, there's no need to add it. It's fine. Yeah, no need that. Okay, so you just need these 3. Okay, our string q dot kernel, vector at kernel. Sorry, you need also this namespace. This 4. Okay, this 4. For simple vector add, actually it comes from, this one comes from here. Come from here. Okay. here, which is this one, simple vector. I call it simple vector. Here is actually main. Yeah, copy it and then change it to void simple vector. You just copy and paste. No change there, exactly the same. And this vector add, this function and this function comes from here to here. Vector add and zero vector add come from here. From not this code, come from here.
Okay.
They come from here. Alright, just that I change the name here, main, to zero vector add, that's all. You just copy and paste. Get it? Okay? So that is for the P3 GPU.cpp. Alright? Okay, next. Next is this q.kernel.cu. This q.kernel.cu, I copy exactly the same from this guide. You go down there. Sorry, down here. I copy this, all this. Copy all that. Copy all this. And I paste it here, and I call it q.kernel.cu. Okay? I copy it, and the only change this, I change this. Okay? The original, there's only one, that include, I remove it, I substitute with this. Okay? Because that one is for the old library, this one's for the new library. We will not work on the old library. Okay? So I changed that. The rest is the same, only that is changed. You just copy and paste, and then you change this. Well, okay, next. q.kernel.ch, which is this one. I add this. Where this one come from? This one actually come from here. Just copy and paste. Go back here. Copy this, and then paste it here, and then add the semicolon at the back. Not colon, semicolon. Semicolon is like this. This is colon, semicolon is this. Okay, there's a comma there. This is colon, this is semicolon. Okay, semicolon at the back. And just copy and put it, and then save it. So that is q.kernel.cuh. Okay? Right? And this is q.kernel.cu. Okay? And this copy and paste from the guide from the website, and just change to this, which is basically from the website. Okay? So that's very simple. And I add this too. Let's look at the c.cu file first. Okay, this one exactly the same like what you see just now. I just copy and paste, except that the first one I add in auto string because I use cout. Okay. Also, I add in this using namespace. Right? And then here, exactly the same like what you see just now, except that I remove the content. This one is exactly the same like I copy from here. Okay, exactly the same. Just that I remove the content. Remove the content. You have to put it back, and then double. I change it to integer because the problem that you're solving here is integer. Okay, integer. Okay, this element here is all integer. Okay, and I call a GPU vector f. Okay, it's all integer. This one exactly the same, like the content inside there, I remove it. Okay, because it needs to be integer this time, so you have to bring it back. And remember, this one is integer. In the original file is double. This one changed to integer. Okay, I remove this because, as I said before, you need to do some change here. Okay, but it's more or less the same. Okay, the next change is I do this. Instead of 512, I put it 1024 because our problem is 1024 maximum. Okay? And that's the maximum number of threads inside the x dimension. Okay, we got X and Y and Z. Okay, X and Y and Z. This dimension, the maximum is 1024 for this GPU. Okay. Right, and then here also the same. I change it from 512 to 1024, and here I remove it so that you have to fill in with the information, relevant information after I make this change. Okay, but they are more or less the same. Just change some part. Okay, and then here, this code is exactly the same like this code here. This serial. Okay? Is serial vector F. I just copy this, copy that, and I rename it to parallel vector F. Okay, so everything is exactly the same, except here I change from vector F to GPU vector F, because this one is going to be solved by the GPU, but the rest is all the same. Okay. Return 0 here I remove as well. Okay, so that's all. Oh, sorry. This is last part. Last part is I define size, which is here. I brought parallel vector, which is the name just now, and I put it into the .c. Okay, and then I include it inside my P3 GPU.cpp. And also inside my vector at kernel.c. Right? Is that clear? So that's all that I changed just now.
好，他刚才讲的是一样的，就是要让一样的东西，是
是，
好像是，
我以为是要让那个
你改不东西。
知唔識得放啊 email 俾我？
这个是你自己改的，
其实一样的 track ID 跟 T。
You can check under the profiler which is next. If it is not run by the GPU, then you see this one empty. Then this profiler is going to tell you, because this profiler is actually profiling the code that is running on the GPU. And you can see the percentage here, how much time. The screen is small, but you can see here how much time in percentage and how much time in actual time. If you see this one blank, that means it's not executed in the GPU. Yeah, the profiler will tell you. Yeah, the profiler is going to tell you all. How much time is spent on other functions here. There are a lot of functions there, right? Okay, finish it. It's finished, then we can proceed to that. Done.
Done.
Done. Okay, let's move on to the other one. First thing is, you need to ensure that the environment is configured properly. Otherwise, you will not be able to see this NVIDIA profiler, which is called NV4. It means NVIDIA profiler. Okay? So you need to include certain things or DLL, this is a direct library, make it visible so that NVIDIA profiler is able to see. Okay, first things, go to the system properties. By pressing this Control R, oh sorry, actually it doesn't, never mind. You go to here and then you tap in this. Type in sysdm.cpl. Sys okay, click on it. This thing will come up. Go to advanced, go to environmental settings. Okay? Click advanced, click environmental settings. And then go to path, add new path. But before you add new path, I think it's already there. Check first. Go to path. And I think double click on it. And check inside here whether it's there. Okay, what you need to add is you want to add this. Okay? But don't copy this exactly because our version is different. Yeah, our version is different as well.
Yeah.
Let's see what whether it's there.
I did.
Okay, let's try this first. Let's try whether it's visible without doing all this. Okay, what we need is we need to open up we need to open up PowerShell. Okay? Open up PowerShell is first thing you have to go to the code first, right? Okay, what you do here is go to here, go to your project file name, go to open folder in File Explorer, so open up. Okay, your CUDA, everything is here, right? New. Sorry, I think it's this one. Option. Sorry, not the one. This is different. Show. I think put here somewhere. Maybe put here. Right click. Open the menu. Two more options. Sorry. Open the menu. Okay. Open the menu. Right. So the PowerShell will be there. And this is the folder that we're in. Okay. Okay, next. We follow this step. See whether it's able to get it. Type in NVCC. 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 Move to file. Okay, we see this. That means we have done the first part already. No need to do anything because you can see the NVCC. Next is NVPROM. If you see the error, that means it's good. If you see this NVCC error, that means it's good. That means you can see this DCC. Next is this. And there's no result. This is bad, but good, I'm not sure. I think it's good. And we pro, that means you can see this. So we don't have to configure. Okay, next is your compile path and executable. Okay, let's see where it is. It is inside this folder. Go to x64, go to release, and the code executable file is in here. Is it? I think it's this one, it's not this one. No, that's not the one. Where is the code? It's not there. Code is not here. Okay, when I open up, I'll be in here, right? I have to get up first. Get up one step to the parent. Click on this. And then go back to, sorry, I'll go back. Go to x64. Go to release. And it's there. Okay? So you copy this. So I think it will P3 here. P3 dot, sorry, underscore P3U. .txt. Copy this here, okay. And withdraw, paste it here. Press enter. Oops. That means the program is there, it's running. I think you cannot see the end withdraw. That means you cannot skip a step. Go back to this tutor and all that. So let's go back to here. Program file, evidence view. Let's go there. Go to C. Go to program. Sorry, go to here. Go to this PC. Go to C. Go to either one of these. Let's try this one. Check whether NVIDIA GPU. NVIDIA GPU is not there, so it must be here. NVIDIA GPU. Oh, yeah. Okay. I think it's corporation. If I'm not mistaken. It's changed already, right? Yeah. Oh, sorry. It goes to NVIDIA GPU toolkit. Sorry. Go to here, go to CUDA, go to version 11, and then go to extras, and go to cookie, and go to library 64. It's here. So copy this. We need this, some of this folder, right? Yeah, right. We need this the other. Okay, copy this. And then paste it here. Paste it here. Edit. New. Paste. So right now, if you open up, you can see this thing. Okay? Alright, click OK. Let's try again, see whether it works. We still have one problem. Maybe it's this one. We have to add this host 64 x86. Make it add this. Okay, which is Microsoft Visual Studio. Microsoft Visual Studio, let's go. I think it's this one still. Microsoft Visual Studio, it's 2022, professional. VC, which is this one. Tools. And Microsoft Visual Studio. Or there are multiple versions there. Choose the latest one. The latest one must be this one. 1439. Okay. Choose this. Choose bin. Choose host 64. I think it should be x64, not 86. Okay. Choose 64. Then the CL is there, and I believe every port must be there. Let's see the port there, the CL. There as well. Never mind. Let's start adding it. So copy this, go back to here, go back to here. Sysdm.cp now. Enough. Advanced. Go to environment. Go to R. Add another one, which is this. Click OK. Click OK. Click OK. Sorry, you have to close it. You have to open it up another time. So every time you do it, you have to close it. Otherwise, it will not take effect. Repro. Now you can see it. Okay, you should see error, no application specified. If it's empty, then something is wrong. You need to see this error. Okay. So what I've done is right. So let me show you how it looks like. Sysdm.cpr. You go to advanced, go to the environment setting, double click on this part, add these two lines here. This one and this one. These two. Okay. You can play a snapshot of 100. Oh, sorry. You cannot make it bigger. Okay, it's program file NVIDIA GPU Computing Toolkit QDAO version 11.7 extras put P and then link 64. Okay, the second line. The second line is is program file Microsoft Visual Studio 2022 Professional VC Tools MSVC 14. You look at your version. My latest version is 1439. Yours is the different version. And then bin host 64 and x64. Inside the document is x32. But choose x64 because we compile for x64. Okay? So don't choose the x86, choose x64. Okay, at the end, once you add the end, now you should be able to see both. You have to close first. If you just now you open it, you have to close it first, then reopen the new one. Okay? If you type NVCC, you should see NVCC fatal error. If you type NVPro, you should see error. If you don't see anything like this, it means that you have done the configuration wrongly. Okay, so right now, I'm ready to run this program. So let's do this. .exe of videos, and then paste it here. It's not supported on this device. We completely through. Sorry, we already have first. Okay, I go and find the virus. It should be able to trace, but I think there's some problem here. It says that our CPU is our GPU is a better version, and this one does not support the better version. Maybe we have to update to version 12 maybe. Version 12 now. If that's the case, now I need to ask that system to come in and then reinstall it to the latest version. Actually, the latest version is 12. I think we have to install a new one, otherwise it will not. Because I think this review is the latest. I need to get the light system to install first. Next week we will try this. 生意，丁家曼，甘威颂，格曼达西尼，胡威利，Jackson Chai，罗永进，李胜泰，赖胜泰，刘维正。林嘉义、林威汉、张春厚、王金顺、潘优梦、张立涛、潘章汉。张生记、汤修任、汤文浩，汤文耀、王书立、李章娟、张娟、Okay. 一张瑞，Okay, if I cannot run random compiler, maybe because our GPU is the latest version, and we might need QDAL version 12. We are using 11.7, maybe because of that. Alright? So I need to get the lab system to install this one first. Then next week I hope that we can get it. Okay? Okay, you can go now. I'll see you in a short while in the lecture. Okay, you can save it. When you save it, you do it this way, otherwise your program is going to be big. You go to build, go clean solution. Clean the solution. Okay? And then right click, go to open folder, it's in here, but don't save this because this is just partial solution. You have to go up one step. Here, this is the solution that you want. It must be inside the project. So you go to repo, get P3 GPU, zip this one. Okay? So when you open folder is actually inside it. It shouldn't zip only this, right? It should go to repo. You go to repo, zip this whole thing because they want this solution. This solution is all the settings that you make. Okay? So zip this. It's going to be big as well. I think it's about 24 megabytes. So compress this. Oh, sorry. We see no permission allowed. Click OK. Close this one first. Okay, then only you can see. Okay, the size is about 28 megabytes. Okay, if you don't clean the solution, then it will be more than this. It will be 100, 200 megabytes. Sometimes it can go to gigabytes. Okay, depending on what you have inside there. So it's going to be very big unless you clean the solution first. Okay, you get to this folder, close your Visual Studio and zip. Okay, if you don't close your project, then you're not going to zip. Okay, you can always go back and then click on the solution. Okay, it's P3 GPU solution to open it up. Okay, now you open the solution, not the VS project. If you click on VS project, all this setting will be gone. Okay, all the settings that you make here will be gone. You have to also zip your solution as well. Okay? And then you can upload it to your Google Drive or save it to your hard drive. Okay, I'll see you later. You can go now.